How we doing, everyone? Now we're going to look at those questions you had from the night prior. We're going to look at questions 10, 11, 12, and make sure that we're doing them correctly with variables on both sides. So we talked about in class how we want to make sure, and typically we always want to have a positive variable. You guys like having positive variables. You don't have to worry about negatives and everything like that. So this is why we draw this vertical line in here to represent our equal sign, because then we look at the possibilities for how do we get a positive variable. First thing we have to do, make sure, again, this is review, but move your variables first. That is paramount. That's the first thing we have to do. In this case, you have two options. We either have the negative 2y here, or we have the negative 4y. And we have to make a decision of which one we want to move. So we talked about in class, how would you move a negative 2y from this left side to this right side? We can't just pick it up and move it. We have to give an operation to it. And we know that we would have to add the 2y to the negative 2y, and to the other side, the negative 4y. But again, this is where we have to look at it and say, well, are we going to get a positive variable? So what I'm doing in my head is I'm doing a little problem solving here and thinking this through. I'm not actually writing this out, but I'm thinking this through. Well, I know that negative 2y plus 2y is 0, so okay, that's fine. But then over here, negative 4y plus a 2y, that's a negative 2y. Is that really what we want? Now, we can get around that. We can still solve the equation that way, but I think a lot of us are more comfortable with the positive variable. So in that case, that's not going to be my first step. Actually, I'm going to go with the opposite, make my vertical line again, and now I'm thinking, well, what happens if I add 4y to both sides? In this case, I know that negative 4y plus 4y is 0, and then I also know that negative 2y plus 4y is a positive 2y. And that's where I think we will be most comfortable. So we did our correct step in here. Now everything else, the negative 3, can drop down, as can the 13. We did not touch that. So first thing is done. We moved our variables first. Next, we have to make sure that our numbers are on the same side. So in this case, we put all of our variables on the left-hand side. We don't have a y on our right-hand side here, so we have to take the negative 3 and we have to move it from the left side to the right side. And this is what we talked about before. We're going to add 3 to both sides. And that's nothing new because we've solved equations that way. I know negative 3 plus 3 is 0. I can drop down my 2y because that is unchanged. And now I have a 13 plus 3, which we know is a positive 16. And last step, you already know, divide by 2 to get that 1y, which we did, and therefore we have y is equal to 8. Okay, so all my steps are now done. I'm going to take a look at my check. I'm going to substitute in this 8 every time I see a y. So I have negative 2 times positive 8, and then that result minus 3. And then again, I have a negative 4 times positive 8 again, plus 13. And these need to be equal. They need to be equivalent. So negative times a positive in here, that is a negative 16 minus 3. And that's equal to a negative times a positive, that is a negative 32 plus 13. And now I just evaluate. Here I have same signs on this side of the equation, so I add and keep my sign, so I'm at a negative 19. And then over here I have different signs, so again you're thinking, hey, what's 32 minus 13? Well, that's 19, and the higher number was negative, so this is a negative 19. Negative 19 is equal to itself, therefore we know our answer here is correct. Okay, now let's see how you did with number 11. Should have tried it already. The first thing you see, again, do we have variables on both sides? We do. And I can see that just by drawing my equal sign. That's splitting both sides of that equation. Another thing you should really look at as well is not only are we getting our variables along first, or excuse me, variables on the same side first, but also I look right here and I see distributive property. That was something that we've done before. So the first thing I'm going to do first in this problem is I'm going to distribute that positive 5 to both m and the positive 2. We know that 5 times m is 5m, And then we know 5 times 2 is positive 10. Did I change 3m plus 8? I did not, so I'm just going to drop that down. And now work to my next step. Again, now that we have variables on both sides, move the variables first. That is paramount. And which one will give us a positive m? Well, if I was to move positive 5m, we would subtract 5m. Is that what we really want to do here? What would 3m minus 5m give us? Will that be positive or negative? Well, if you're not comfortable with those negatives and you know, well, 3m minus 5m is actually a negative 2m, you probably don't want to do that step then. What we could do, though, is look at, hey, well, I have 3m. If I would have to subtract that 3m in this case from both sides, which actually does give us a positive 2m over here. So I know 3m subtracted by 3m is just 0. So I can drop in that 8 because that was untouched. I can drop in the 10 because that was untouched as well, and it's a positive 10. And now 5m minus 3m is positive 2m. Now from here, just need to subtract like we've done before, the 10, because our second step was move the numbers. So numbers on the same side then. In this case, all the variables are on the left. I have to move the numbers to the right, so that's why I'm subtracting the 10 in here. That'll just drop down, so that means the 2m is dropping in. The equal sign will drop in. And 8 minus 10, we know, is a negative 2. Then divide, again, like we've always done, by that positive 2 to get 1m, and 1m is equal to negative 1. Time for a check. I'm going to substitute in that negative 1 for m. So this is negative 1. I shouldn't put that in a big parenthesis, so I'm going to erase that. Plus 2 inside that parenthesis, I'm just dropping that in. And that's equal to 3 times negative 1 plus 8. Let's focus on one side at a time. In here, I have parentheses, so I got to take care of that first, which that would be 5 times 1. And now I'm going to focus on my right side. Over here, order of operations, I need to do multiplication first, which 3 times negative 1 is negative 3, and then plus 8. Left side, 5 times 1 is 5. Right side, negative 3 plus 8, that again is a positive 5. Answer is then correct. So here's our last one for today. Number 12, when you're solving this one, there are several things we have to do first. What I notice is you have actually 2 distributive property problems to solve in this case. All right, one where we're distributing a positive 2, the other one we're distributing a negative 2. So this is the first thing we're going to look for. So again, if we can distribute, do it first. Okay? If you can distribute. So in this case, we're going to go through and distribute on both sides. So first of all, I'm going to distribute a positive 2, and if you notice, I'm circling that positive sign with it. All right? I'm going to drop down the 6x because I'm not distributing that. I'm just going to drop it in because that's unchanged. And I'm going to take 2 times x, which is positive 2x, and then 2 times negative 1, which is a negative 2. On the right-hand side, I'm not distributing this negative 4. I'm distributing, positive 4x. I'm distributing negative 2. So in this case, the positive 4x I'm going to drop down, and then negative 2 times positive x is negative 2x, and then negative 2 times negative 3 is a positive 6. Okay? So now I've distributed. I don't have any more distributive property. Now I look to combine any like terms that are on the same side. Well, in this case, that's where I draw this guy in here, because that will tell me, can I combine stuff on my left and right side? Well, here's what I have. I take a look at the left side first. I'm not going to focus on anything over here. I'm going to look only at the left side. 6x, positive 2x. Are they like terms? They are. They have the same variable and they're raised to the same exponent. Therefore, I'm just going to combine these together. I'm not going to subtract. I know a common mistake is to go through and subtract 2x and 2x. Well, 2 reasons why that's wrong. Number 1, technically in here, we can't really go through and subtract 2x from both sides from over on one side, because then we'd have to subtract it all the way over here, which in that case, technically that's a 4x. So that's a common problem that we see. The other thing is you're not really balancing the equation. So we want to go through and combine these like terms, which in this case, 6x and positive 2x actually gives us positive 8x. Now, the minus 2 was unchanged, so just drop that down. And that's equal to, again we have like terms with the 4x and the negative 2x, which that actually gives us a positive 2x. And again, this 6, unchanged, drop it down, drop it on in. Okay, from here, I actually made a little mistake in there. First thing we're going to do, obviously we said move our variables first. So in this case, I'm going to subtract the 2x from both sides because, again, I'm getting that positive variable. Because I know 8 minus 2 is actually a positive 6, so therefore I'm going to write my work up here so I have more space. So that's a 6x minus 2 is equal to that positive 6. And in this case, we know to solve this two-step. Add 2 to both sides. So I have 6x now is equal to 8. Divide by 6, and again, this is why we use a fraction, because I know clearly 8 does not equally divide by 6. But I do know that 8/6 shares a common denominator, or a common factor, which is actually 2. So divide top and bottom by 2, I actually get x is equal to 4/3, and that is our final answer.